Welcome back to Everyday Nuggets. Electricity is one of the most fundamental forces that powers our modern world. From the lights in our homes to the devices in our pockets, electricity has transformed human civilization in ways our ancestors could never have imagined. But have you ever stopped to wonder how electricity is actually made? The process is both fascinating and complex, involving multiple stages of energy conversion that harness the fundamental forces of nature. At its core, electricity generation relies on a simple principle discovered by Michael Faraday in 1831. When a conductor moves through a magnetic field, an electrical current is induced. This fundamental concept, electromagnetic induction, is the foundation upon which nearly all our electricity generation is built. Modern power plants, regardless of their energy source, operate using this principle. They convert some form of energy, be it chemical, kinetic, nuclear, or solar, into the rotational motion needed to spin generators that produce electricity. The difference lies in how they achieve this initial energy conversion. Fossil fuels, coal, natural gas, and oil, currently account for approximately 60% of global electricity production. But how exactly do these ancient remains of plants and animals become the power that charges your smartphone? The process begins deep underground, where these carbon-rich fuels formed over millions of years. After extraction, they're transported to power plants, where they undergo combustion. This controlled burning process releases their stored chemical energy as heat. This heat is used to boil water, creating high-pressure steam that expands rapidly. The expanding steam pushes against the blades of a turbine, causing it to spin at incredible speeds, typically 3,000 to 3,600 rotations per minute. The turbine is connected to a generator containing powerful magnets, surrounded by coils of copper wire. As these magnets spin past the wire coils, they induce an electric current, transforming mechanical energy into electrical energy. What's remarkable about this process is its efficiency in converting raw energy into a form that can be easily transmitted, distributed, and utilized. However, this convenience comes at a significant environmental cost, including greenhouse gas emissions and air pollution. Nuclear power plants operate on a fundamentally different principle than fossil fuel plants, though the end result, spinning a turbine to generate electricity, remains the same. Instead of burning fuel, nuclear plants harness the energy released during nuclear fission, the splitting of uranium atoms. This process begins with uranium fuel rods placed in a reactor core. When a neutron strikes a uranium atom, it splits the atom, releasing enormous amounts of heat energy along with more neutrons that continue the reaction in a carefully controlled chain reaction. The heat generated converts water into steam, which then drives turbines connected to generators. The key difference lies in the energy source. Nuclear fission releases approximately 1 million times more energy per unit mass than chemical reactions, such as combustion. Nuclear power provides about 9 to 10% of the world's electricity and produces minimal greenhouse gas emissions during operation. However, it comes with challenges, including the management of radioactive waste and the potential, albeit rare, for serious accidents to occur. Perhaps the oldest form of industrial-scale electricity generation, hydroelectric power harnesses the kinetic energy of flowing water. Unlike fossil fuels or nuclear power, hydroelectricity doesn't require heat to generate steam. It directly converts mechanical energy into electrical energy. In a typical hydroelectric dam, water accumulated in a reservoir flows through intake structures and into enormous pipes called penstocks. As the water descends, gravity increases its speed and pressure. At the bottom, the water strikes the blades of a turbine, causing it to rotate. This rotational energy is then transferred to a generator, which produces electricity through the process of electromagnetic induction. Hydroelectric power accounts for approximately 15% of global electricity generation and is praised for its reliability and longevity. Nuclear power stands out for its incredible efficiency and environmental benefits. One of the most remarkable aspects of nuclear power is its efficiency. A single uranium pellet, about the size of your fingertip, contains as much energy as 17,000 cubic feet of natural gas, 1 ton of coal, or 120 gallons of crude oil. That's an astonishing amount of energy packed into something you could hold between your fingers. Despite misconceptions, nuclear power is one of the cleanest energy sources available. It produces 0 direct carbon emissions during operation. The steam you see rising from those iconic cooling towers? That's just water vapor, not smoke or pollution. In fact, nuclear energy prevents over 470 million metric tons of carbon dioxide from entering our atmosphere each year, equivalent to removing 100 million cars from our roads. But what about the waste? While nuclear waste management is a challenging task, the industry has developed sophisticated containment and storage solutions. The total high-level waste produced by American nuclear plants over the last 60 years would fit on a single football field stacked less than 10 yards high. Compare that to the mountains of waste from fossil fuels. Let's turn our attention to renewable energy sources, the fastest-growing segment of electricity generation worldwide. Unlike fossil fuels or nuclear power, renewables harness naturally replenishing resources. Solar power converts sunlight directly into electricity using photovoltaic cells. When photons from sunlight strike these specially designed panels, they knock electrons loose, creating an electric current. Modern solar farms can generate hundreds of megawatts of power. At the same time, residential installations allow homeowners to generate their own electricity and even sell excess power back to the grid. Have you ever stood beneath a wind turbine? These gentle giants transform the kinetic energy of moving air into electrical energy. As wind pushes the massive blades, some spanning longer than a football field, they rotate a shaft connected to a generator, producing electricity. A single large turbine can power several hundred homes. Hydroelectric power, as discussed earlier, uses flowing water to spin turbines, providing reliable electricity that meets about 15% of global demand. From massive dams like the Hoover Dam to small run-of-river systems, hydropower offers consistent generation that can be quickly ramped up or down to meet fluctuating electricity needs, a valuable feature in our increasingly dynamic power grid. Geothermal energy taps into the Earth's internal heat. By drilling wells into underground reservoirs, we access hot water and steam that can drive turbines. This process provides consistent power regardless of weather conditions, making it an excellent baseload energy source. Biomass energy converts organic materials, like wood, agricultural waste, or even garbage, into electricity through direct burning or conversion to biofuels. While not completely carbon neutral, biomass recycles carbon that is already part of the natural cycle, rather than releasing long-sequestered carbon from fossil fuels. Once electricity is generated, regardless of the source, it enters the electrical grid, one of humanity's greatest engineering achievements. This vast network of transmission lines, transformers, and distribution systems delivers power from generation plants to your home at the exact moment you need it. The grid operates at high voltages for long-distance transmission, reducing energy loss. Step-down transformers then convert this high-voltage electricity to the safer 120 to 240 volts used in homes and businesses. This complex system requires constant monitoring and precise balancing of supply and demand. Thank you for watching another episode of Everyday Nuggets. If you enjoyed this episode, please like and subscribe for more videos. If you have suggestions for other everyday things you'd like to know about, please leave them in the comments below. Stay curious